Again, this is 0 minus 0. So again we got 0. So when it was this situation, up and down and down and up, it is actually now we have written the state in the form of linear combination. And now this is 0, 0 state. Is here we are having 3 states. Inside given S equals 1, here this is S equal to 1. Inside S equal to 1, we are having 3 configurations here for M equal to 1, M equal to 0, and M equal to minus 1. So we call that this is the triplet configuration. In modern physics, I hope you have seen something like this triplet configuration. Now, you are studying modern physics. Not now. And here, we are having singlet configuration. Means the atom as a whole can be in triplet configuration and can be in singlet configuration. You can check this thing. Okay, and MRL. In MRL, we are having a UV-Vis NIR spectrometer. And this spectrometer we are having, its model is lambda 1050. Right? It is having the resolution of 0.1 angstrom. 0.1 angstrom is the resolution of this spectrometer. And with this, we can see a triplet configuration of an atom or singlet configuration of an atom. Will you measure its spectrum? Its spectrum, then it's something like this, that it is having 3 peaks like this. When it gives you a peak, when an ordinary UV-Vis spectrometer gives you a peak, you can further resolve with this. This is very advanced one, and 1050 lambda 1050 is the latest one the Perkin-Elmer has made. So, if you further resolve a peak, you will see that there are 3 individual peaks in it. And this we call a triplet configuration of an atom. And sometimes you have, even if you resolve, you are having single peak here. You call this singlet configuration. If you can make the sample, because the sample preparation for this is very crucial, then I can arrange you a visit to the MRL, and over there you can see in your sample that yes, it's a triplet configuration or it's a singlet configuration. For that, sample preparation is a crucial thing. If you get that one, you can see such configurations. Okay, so we can have this thing. Now, in order to test our mathematics here, that whether we did right or not, you are having one problem in your text. You can find the number of that is 4.27 probably. And what if we apply S minus? What if we apply S minus on this state? S minus on Sn state, which is S minus on this state, 1, 0. 1, 0. You remember we applied S minus on half, half. Similarly, we can now apply S minus on 1, 0 state, which is this one. And we can see the result of it. If I apply S minus, then utilize this formula here. And your S is 1 there, while M is equal to 0. So put S equal to 1. 1 and 1 plus 1, 2. So 2 here, this whole term will become 0. So you got square root 2. You got square root 2 and h bar. H bar is this one. Then come here. S is 1. And M is becoming M minus 1. So 0 minus 1. So it came out to be 1 minus 1. Got it? Yes. So 2 square root h bar is the eigenvalue, and 1 minus 1 state. Which state this one is? 1 minus 1 state is 2 arrows down. So you got here. How you started? You applied S minus on 1, 0 state. 1, 0 state is this one. Means you applied S minus on 1 over 2. Okay, so S minus on 1 over 2 and this state. Up, down, plus, down, up. And you got 2 h bar, this state. Clear? So the state has changed to this one. Earlier what you did, you applied S minus on this state, 2 up, and it converted into this state. When you applied S minus on this state, you converted it further down. So look here, you applied S minus on this one, you got this state. You applied on this one, you got this state. So these are the 3 possible configurations. These are the 3 possible states. Got the idea? Yes. Now we apply. Now what about this one? The same now you do it in the reverse. If you apply S plus on this state, S plus on this state, what you will get? You will get this state. This is raising operator. Raising operator on this one, you will get this state. You apply S plus on this one, you will get this state. Clear? You apply S plus on this, you will get 0. You apply S minus on this, you will get 0. You do this when you go home, you apply these conditions, and you will have the confidence that yes, these are the possible states, and they are going, means the raising and lowering operator is actually going there. Similarly, if you apply, this is one part of the problem as well, S plus minus on this state, 0, 0 state. This is another possible combination. This is a state. This is a singular state. So S plus when operated on this one, what you will get? Tell me. Will you operate S plus on this? What you will get? Or S minus on this 0, 0 configuration? What you will get? You will get 0. Why? Because it's a singlet configuration. In this configuration, there is no any other state possible. So you apply plus on this one, you will be in the same state. There is no further state up or down this one. As you are going with S plus on this, you are going there. With S plus on this, you are going there. Because 3 states were there. 3 possible configurations, which we call triplet. On this one, it's singlet. So when you apply S plus on this, this is the only possible state. No other state above this one. So you will get 0. You apply S minus on this, it's the same story as you did here. This is like a singlet state. You apply S minus this one. S plus on the up, there is no other state possible. So you will get 0. S minus on down, you will get 0. Clear? So this way, you can prove this one. We will solve this one that yes, this coming out to be 0. So write, this implies that S minus, I am solving this part of a problem. This one we did. So now we are doing this one. So S minus on half, and what is S0, 0? This is 0, 0, this state. It is 1 square root up, down, minus, down, up. And now write S minus is a double combination, because S minus will have S minus 1, S minus 2. Because S minus 1 will operate on the first state, S minus 2 will operate on the second state. So I can write that this is S minus 1 plus S minus 2, and it operates on this up, down, and down, up. Clear? Now what it will be? It will be equal half. So take this thing, take it out as common. S minus operates, S minus 1 operates on this up, while the other will remain with this. Then minus, right? Minus, apply this one there. So it will be plus half and S minus 2. S minus in 2, and it will be on the down, while keep this one, we will have to keep this one out. What we did? S minus. S minus, we are operating on this state. S minus, we decompose into 1 and 2 states. So, S minus, when S minus 1 will operate on this one, what will happen? 1 over 2, and as it is of the state 1, so it will apply on this one, it will remain with this. like this. Then is 2, this is minus 2 will operate on this one. So it will remain out and it will operate on this one. Then minus and these two will operate on this. Clear? So minus and 1 over 2 and it will be is minus 1 and it will be on the down because this one is down and this will remain with it minus 1 over 2 and the down will remain as it is and S minus 2 will operate on the up state. Clear? Yes. 2 terms here, 2 here. So it will make these as 4 terms, 2 into 2. Clear? Yes. Any confusion? You apply this is minus first on this pole and then is minus on this pole. What I did, I applied is minus on this, then is minus 2 on this. Then is minus 1 on this is a whole and then this is minus 2 on this is a whole. You can do both ways, no problem. You apply is minus 1 on both of them, then is minus 2 on both of them. The result will be the same. So what will happen now here, that what this will make, this is S minus operating on 1. What it will do? It will generate H bar, not H cut. H bar. Okay? H bar, it will make it down. So you will get H bar over 2 and it will make it down and 1 is this one. Clear? Okay. Plus, when this operates, it is minus and it is down. So it will make it 0. This will become 0. It's not good. So this will come out to be 0. And when it's minus on this, it will make it 0. And what about this one? It will make it minus H bar and square root 2. Down 1 is here and this will be down. And what's the result? 0. This and this are cancelling and you got 0. Clear? Yes. So what you did, you proved that when you apply S minus S plus on, we only proved S minus, right? We only proved S minus on 0, 0. You can prove back home S plus as well. I can tell you that one as well. S plus, you will write S plus 1, S plus 2, you will apply on them. So here you will get minus H bar over 2 up. And here you will get plus bar H over 2 up, and they will cancel. And you will get 0. So the raising and lowering operator on the singular state will give you 0. While on a triplet state, it will move a state up or down. Clear? Yes. So this is the addition of angular momenta. You can prove that all these states, you can prove that all these states, whether they are triplet or they are singlet, they are the eigenfunctions of S squared. S squared being your spectrometer. spin operator, the total spin you call. So we can prove that one as well.